the matrix and determinant. So first we define matrix. Let us consider this system of linear equation. So the coefficient of x, y, z along with the constant terms can be placed in some order. Following arrangement makes some easy to system design. So this x plus y minus 2z minus 4 equal to 0. These are also x, y, z. This is x, y, z. We arrange these coefficients. So the rectangular array is an example of matrix. So this is an array. So 1, 1, minus 2, minus 4, 3, minus 2, minus 1, 1, 2, 11, minus 5, 7, like that. So this is an array. So this is an example of matrix. So we arrange this and this is, so for this we use this bracket. We use this bracket, round bracket or square bracket. So we arrange this 1, 1, minus 2, minus 4, 3, minus 2, minus 1, 1, 2, 11, minus 5, 7. So this is a matrix. So this row elements means one equation, and this column elements means the coefficients of x, coefficients of y, etc. Then this rectangular array is an example of matrix. The horizontal lines, these are rows and these are columns. So row number, column number. So this we say this element has entry aij. This aij is entry. So first we say row number and column number. So row number we write here. This is, so this is 3 rows and 4 columns. So when we say aij, these are the entries aij. So I will vary from, I is the row number and j is the column number. When we say a to 3, so 2 is the row number and 3 is the column number, means a to 3 is the element minus 1, like that. Now this aij, I is the row number and j is the column number. Then row matrix are a matrix having a single row is called row matrix, and column matrix is a single column. So single column means there are 4 rows and one column. It is 4 by 1 matrix, and here it is 1 row and 4 columns, so it is 1 by 4 matrix. Rectangular matrix, if m is not equal to n, then it is rectangular matrix. If m is equal to n, then it is square matrix. This is diagonal matrix. So this is a square matrix, and m equal to n. These diagonal elements are non-zero, but other elements are 0. So this is diagonal matrix. Zero matrix is here, this one, every element is 0. Then identity matrix is this diagonal matrix, only this diagonal elements are 1 and others are 0. The diagonal matrix whose elements is the principal diagonal means this diagonal. Then this matrix is called identity matrix and is denoted by I. Then singular and non-singular. Singular matrix means it is if determinant of A. When we have a square matrix, we can find determinant. We will discuss about this later. So this determinant is equal to 0. Then we say A is singular matrix. Then non-singular matrix, otherwise we say non-singular. Then symmetric matrix is this diagonal. First we keep this, write this diagonal, then every element coincides. If we fold it, then they will coincide like this. So 3 goes to 3, 1 goes to 1, minus 5 goes to minus 5, etc. Then skew symmetric matrix is this one. Then matrix addition, and this is matrix. And when you say about determinant, determinant is what? Determinant is this is, so determinant is what? We'll explain here. So determinant is we use this bracket for determinant. We use this bracket. This is also array. This is also some array. Say 2 4 6 1 minus 2 1, say 0 4 1. So this is also arrays. This is also array. So our bracket is here. In case of matrix, we use round bracket or square bracket, but here we use this modulus bracket, aij, this bracket. So here it is third order determinant, means a row number equal to column number. And in case of matrix, we may not have this row number equal to column number, but here in case of determinant, we must have this. Now this for determinant, we can evaluate this to some number. We need we can simplify this this with the help of minor and cofactor. We expand it. We can have some value. Say suppose it is second order determinant. Say it is second order. Say it is 6 3 1 4. So this is a second order determinant, and its value is 6 into 4 minus 3 into 1. It is 24 minus 3. It is 21. So this determinant, does the entries are all numbers, and we can evaluate it to some value. That we encountered here with this one, singular matrix. This singular matrix. So what we meant here, this determinant A equal to 0 means A is a square matrix. So if A is this, so if A is this, 2 1 minus 2 4, so A is this, then when we say determinant A, it must be a square matrix. To determinant A, we write this as 2 1 minus 2 4. So this is determinant A, and we can evaluate it. When we say it is matrix, then we can't evaluate to some value, but when we write determinant, we can have 4 into 2, it is 8, 8 minus 2, it is equal to 10. So this is the case where this determinant means this. Now let us say about the expansion of determinant. So expansion of determinant is expansion of determinant. This is expansion. This is expansion. So minor. So minor means, when we say about minor, this is aij. Aij is a determinant. A so aij is a determinant, means what? Aij are the entries. So A, it is n by n. Then minor of, we write minor of aij, or minor of aij is the determinant obtained from A, obtained from this determinant aij, this parent determinant, by omitting ith row ith row and zth column. So suppose this element, this tree, here this tree is second row, third column. So its location is A to 3. So minor of A to 3 is minor of A to 3, you omit second row and third column. So minor of A to 3 will be second order determinant, and first row is 3 minus 3 and this is minus 2 1. So these are the examples. So here A11 is 3, so we are omitting first row, first column, so remains 0 3 1 minus 2. So this is minor of A11. And cofactor is this one, the minor multiplied by minus 1 to the power I plus j. This is cofactor. So cofactor is, so we write cofactor of Aij is equal to minus 1 to the power I plus j into minor of Aij, and cofactor of Aij we denote it as Aij. We write this capital Aij. So from this example we see this. So minor of A11 is this, minor of A12 is first row, second column. So it is 4 3 minus 2 minus 2. And cofactor is minus 1 to the power 1 plus 2 I plus j. So these are the examples. And when we say we need to expand this. So to expand means determinant, value is. So value is what? So value of the determinant is, so a determinant is given, then this delta, if we write the value, delta is the value of this, say value of this is delta, it is summation Aij I from I equal to 1 to n. J is fixed. Also, if I is fixed, it is summation Aij corresponding cofactor, then we vary j here 1 to n, and this is equal to here we keep I fixed. I is fixed. So in this case the value will be, if we consider the second row, means what? I is fixed, I is 2, then it will be I is 2, so A21 into A21 plus A22 plus A22 plus A23 plus A23. So this is the expansion of determinant. Then properties of determinant. So these are the properties of determinant. So properties, it is if element or every row element of a row, every element of a row or every element of a column is 0, then determinant vanishes. So determinant is 0 then, because if aij is 0 for some I or for some j, then that value will be 0. Then the value of the determinant remains unchanged if rows and columns are interchanged. When two rows of a determinant are interchanged, then its numerical value remains same but sign is changed. If each element of a row of a determinant multiplied by a constant, a is then value gets multiplied by a alpha. If two rows of a determinant are identical, then the value of the determinant is 0. So these are the main properties of determinant. And Cramer's rule is here. Cramer's rule is for solving equation, solving this system of linear equation. So this delta is the coefficient determinant, then d1, d2, d3, these constants would be to the right hand side. So constants d1, d2, d3, these are the values. Then for delta 1, this column takes position of this first column. For delta 2, this comes to the second column, and for delta 3, this comes to the third column. Then we evaluate these values and we get the value of the variables. So this is known as Cramer's rule. Then so to find the value, so find the value of this. So here third row is two elements are 0. So because our definition is this summation aij, so I is fixed, so we keep 3 fixed. So this is a31, so this will be, so this 2 1, what we do, a31 plus a32 plus a33. So what we are having, a32 is 0, a33 is 0, so only we need this a31 is minus 22, and a31, capital A31 is minus 13 into 23 minus 10 into 14. So then we evaluate this one. Similarly, in the second one is what? This second column is 0. Two elements are 0. So this here we make j fixed, j equal to 2. So this we can write this value is this value is a 2 1 2 1 2 1 2 a 1 2 plus 2 is fixed, so row column number is 2, then a 2 2 a 2 2 plus a 3 2 a 3 2. So a1 2 is 0, a2 2 is 0. We need not compute these values, only you can write just 0, and then a32 is 2 into this one into 11 minus 4 into 19. So this is the way to find value of the determinant. And in here we are having this so 3, from this we are taking 3 common. This is from property 4. So 3 you take common, 3 into 14, 3 into 13, 3 into 4. So in this row 3 is a common factor, so 3 you can take in outside. So we are having two identical rows and two identical rows. This will make this way apply property 5. So we get this equal to 0, r1 equal to r2. So this is the way of evaluating this. Then this one, here we are applying properties. So A is taken common, B is taken common, C is taken common. One thing you need to compare, in case of determinant, say 4, say 2 into say 6 1, so this is matrix. We are talking about matrix. In case of matrix 0 4 2 1 1 minus 1, so this is a matrix, and we need to multiply every element. So this will be 12 2 8 0 8 4, and this is 4 I am writing. Then is it 2 2 minus 2. In case of matrix, we need to multiply every element. But in case of determinant, it is not the case. It is not the case. Only one row or one column we can make it. So this here it is A, this one. So this is A. A is coming from this. We can multiply this A to only one column, not everyone. If we take this A inside, then it will come to first column only one column or only one row. But this, so A is going to this column, B is going to this column, C is going to this column. So only one row or one column. So this is something different with this matrix multiplication. This type of multiplication we say scalar multiplication. This is multiplication of matrix. This is scalar multiplication. Scalar multiplication of matrix. But in case of determinant, it is different. So this one we are doing like this. So ABC. So this A is taken common. After taken common this ABC, we get this columns. Now we subtract. So C1 minus C2. C1 minus C2. We are writing this C, first column. So this is C1, new C1. This is new C1. This is old C1, old C2. So this one. Then C2 minus C3. This C2 minus C3. This is new C2. And this one. And we can now again take this A minus B from this common. This is B minus C common, and remains 0 1 A plus B 0 1 B plus C, and ultimately we can expand it now easily because two elements are 0. So it is B plus C minus A plus B, and we have this value. It is the right hand side we get. Then this is also, we are making C1 minus C2, C2 minus C3. We are writing this as new columns. Now this one, so we get these values. Then here also it is just like the first one. We are taking common A, taking common B, then A minus B, A minus 1, B minus C. So this one is C1 minus C3, C2 minus C3, so that we can have A minus 1 and B minus 1. Next one is, so these are all using properties. So these are column transformation, these are row transformation. So these are also using properties. Then this problem says prove that x equal to 1 is a root of this. So this is an equation. This is an equation because it can be expanded. We will have some value. So x are variable, x are here. So equation, so the value which is satisfied by x means what? This will make it the value 0. So that value of x is the root. So x equal to, we have to prove that x equal to 1 is a root. So we just put x equal to 1 here. Then what we get here? See, so this is 2 2 2 3 3 3 5 5. Obviously the value is 0. So x equal to 1 is a root. Then these are solution for Cramer's rule. So this is the equation. So for this 2 twice x minus z means coefficient of y is 0. So 2 0 minus 1. Z, coefficient of z is minus 1. Then second row is 2 4 minus 1. Third row is 1 minus 8 minus 3. And right hand side column is 1 1 minus 2. So 1 1 minus 2 is replacing this one. So this is the coefficient determinant. 1 1 minus 2 is taking this position here in second position, and here this is third position. So we are evaluating these values and we can have this value for solution for x, y and z. Then so this is the procedure. Same thing. This is also solved like this. Same. These are the examples. So 1 2 second one, 1 2 minus 1 3 minus 4 5. So this is 1 2 minus 1 3 minus 4 5 7 minus 1 1. So these are the, this is the third one. So this is the procedure. So evaluate this. So to evaluate this 2 3 0 5 0, so just consider this as, so 2 zeros are there. So expand with this first column. So 2 into 2 means it is 2 into minus of 0 minus 10. It will be plus 10. So plus 10 into 2, it is 20. So these are the, so here also consider only this one, 2 into this value. Actually it is 2 into 3 into 4. Then minor and cofactor, you can find it. These are the, this is for properties application. So this one, this is 1 omega cube. This omega cube is, we need to write 1. It is cube root of unity. So you write here 1 1. Then it is 1 1 omega square, 1 1 omega square, 1 omega 1 omega 1. So it can be done. This is a symmetric matrix. Here add all this, R1 plus R2 plus R3. So when we write R1 plus R2 plus R3, this will be 0. So if first row or first column make it 0, then every element is 0. Every element of a row is, or every element of a column is 0, means the value is 0. So these are Cramer's rule. So this is, then matrix is, we have done this matrix, and matrix addition, multiplication, these are the examples. A plus B plus C. A plus B plus C. So corresponding elements is 1 plus minus 3 plus minus 3. Then so AI is means same location values you need to add. Then a minus twice b, so multiply by minus 2 or 2, then 2 into minus 3, it is minus 6, then this is 6, this is 4, this is 4 minus 4, this is 10, this is 6, 0, 6 minus 2, so this is twice b, then a minus b, subtract it. So these are the procedure. Then this is done here, a plus b, a minus b, these are solved. Then AB is, so AB is, it is definition of product. So definition of matrix product is, so a matrix so this is AB. So A we say prefactor, B we say postfactor. So if A is m into n and B is n into p, then we say AB exists. AB exists. This is P. Means what? Column number of prefactor must be equal to row number of postfactor. So AB is equal to CIK, we write CIK is equal to summation AIJ BJ K. Then I and K is here, and J will vary from n number of columns and n number of rows, and AB is of order m by p. This is m by p. AB is m by p. So here you see AB. So this is the definition. So this is 3 by 3, B is 3 by 3. So AB is possible also, BA is also possible. So AB is, so this is, so CIK. So 2 gets C11, 2 gets C11, I is 1, K is 1. So I is 1 means this is I, this is 1, this is 1, this is 1. So this will vary. So first row of A and first column of B. First row of A, first column of B. So 1 into minus 3, 2 into minus 2, minus 3 into 0. This sum will give us this A1, C11. So this is the procedure. So when we say BA, for BA what will do? So BA, because they are 3 into 3, so BA is also possible. So for B we need first row, and for A we need first column. So this is first row of B, this is first column of A. So minus 3 into 1, 3 into 2, 2 into 5. So they are the values are different. So that is why AB is not equal to BA. We will get some different values. So CB is also in a similar way. Suppose we need this value, or we need this value, say, means what? This is C32, oh sorry, 23. So for C23, what we need? Here second row and here third column. So minus 5 into 2, minus 10, minus 2 into 3, it is minus 6. So minus 10 minus 6, it is minus 16, plus 2, plus minus 16, oh sorry, 1, minus 1, this into this. So it is minus 17. So this is the way to multiply. Similarly, A, B, C. So all are 3 by 3, so we can have it. CA, AC. Here you see, CA is this value and AC is this value. They are not same. Then this is the system of equation. How we would have, this is 3 by 3 matrix, this is 3 by 1. So this is 3 by 3. This is 3 by 3. This is 3 by 1. This is also 3 by 1. This is also 3 by 1. So this is 3 by 3. So this product will have 3 by 1. So this is 3 by 1 matrix. This into this, it is 3 by 1 matrix, and this is 3 by 1. So these two matrices are equal. Means what? Every entries are on the same position. They are equal. Then this is the way how we find AB, BA, A square, B square. All are product. A square means A into A. So this is 4 by this is 1 by 4 matrix. This is 4 by 1. So AB will be 1 by 1 and BA will be 4 by 4. Then this is AB. So this is the zero matrix. We are getting this. So these are some examples you can try. And this is all about determinant and matrix. Singular. This is singular, means what you have to do. Singular means determinant A is 0. This is the definition. So determinant A is 0. So write this value. So it is -1, 1, 2, then -2, 2, 4, then 6, 3, 4. So -2, 2, 4. So you can apply property here. So take -2 common or 2 common. Take 2 common from the second row. So you will have now -1, 1, 2, -1, 1, 2, 6, 3, 4. So what we are having, 2 rows are identical, so the value is 0. So this is singular matrix. Is A square minus 3A plus twice I. The I means this unit matrix. So this is A square. A square is what? A square is 3, 1, minus 2, 0 into 3, 1, minus 2, 0. What is this? 9 minus 2, it is 7. Then 3, this is 3. Then minus 2 into 3, it is -6. Then -2, -2. This is A square. Then A square minus 3A. So 7, 3 minus 3A is -9 minus 3 minus say plus 6. This is plus 6 and it is 0. And 2I is 2, 2, 0, 0. So add all this. So 7 plus -9 minus 2 plus 2, it is 0. Then 3 minus 3, it is 0. Minus 6 plus 6, 0, it is 0. Minus 2 plus 0 plus 2, it is 0. So this is the 0 matrix. This 0 means, so this 0 means when we write in case of matrix, this 0 means it is the second order, because A's are all second, so it is 0, 0. So this is all about matrix and determinant.